Welcome to AI in 8 minutes or less, your daily AI update. Today, we're looking at what comes after AI, a technology so powerful it could change the very fabric of our digital world. With everyone laser-focused on the AI revolution, there's another massive shift happening right alongside it, and it's not just an upgrade, it's a whole new way of computing that's on the horizon.
So let's just cut to the chase with a question that honestly gets right to the point. We're talking about everything, your bank account, your crypto, all of it. Is the digital fortress we've built around our assets actually secure?
And look, this isn't some far-off sci-fi plot. This is from a recent paper out of Google that sent shockwaves through the tech world. A calculation that would take the fastest supercomputer we have today, longer than the age of the universe, could be done in 9 minutes. That's not just faster, that's a whole different kind of machine.
So what exactly is this thing, this powerful new form of computing, and how could it be such a threat? Well, to really understand that, we have to go back to the beginning.
The story really starts with this one guy, Nobel laureate John Martinez. His work back in the 80s laid the foundation for everything we're seeing today. In fact, he was just appointed to a presidential science advisory council, which tells you how important this is.
To really get a handle on the threat, you got to wrap your head around his discovery. It's kind of mind-bending. It's what took quantum mechanics from being this weird theory about atoms and proved it could be turned into actual machines.
Okay, so in our everyday world, things make sense, right? You throw a ball at a wall, it bounces off. Simple. But down at the quantum level, the rules just get thrown out the window. A tiny particle can literally just appear on the other side of a solid barrier, tunneling right through it.
And that bizarre little trick, quantum tunneling, that's the secret sauce. It's what lets quantum bits, or qubits, do things normal computer bits can. Instead of just being a 1 or a 0, they can be both at the same time, which unlocks this incredible new level of computing power.
But here's the kicker, the part that changed everything. Martinez proved this wasn't just some weird thing atoms do. Nope, you could actually build this behavior into big electrical circuits. That was the moment quantum computing stopped being a what if and started becoming a when.
So, if we can build these machines, what can they do besides just break stuff? This is where it gets really exciting. This is the creative side of quantum.
Martinez explains it perfectly. Think about how you might use software to design your kitchen, moving things around on a screen before you build anything. A quantum computer could let us do the exact same thing, but with molecules.
And the potential applications here are just staggering. In drug discovery, for example, getting just a few % more insight into how a molecule works could be worth billions. We're talking about designing new materials from scratch, revolutionizing chemistry, and totally transforming finance.
The economic scale of this is hard to even wrap your head around. One report projects a potential value of $1 trillion, with a T, in the next decade alone. Now, that's assuming we find useful problems for these incredibly powerful machines to solve.
But before we can unlock all that value, there's this huge debate raging at the heart of the industry. And it all comes down to what you build first.
It really boils down to this. You can have the most amazing software in the world, these incredible quantum algorithms, but they're useless if you don't have a computer that can actually run them. And building that computer, that's the really, really hard part.
Martinez frames it as this philosophical choice, borrowing from Peter Thiel's book 0 to 1. Do you take the indefinite path, focus on cheaper software and hope you find a use for it? Or do you take the definite path, make the huge, expensive bet on building the powerful hardware you know the world is going to need?
And as Martinez says right here, his company is all in on that second path, the hard one, the hardware-first approach. It's kind of like what NVIDIA did with GPUs before the AI boom really hit. The logic is just solid. You have to build the engine before you can win the race. And that race to build the hardware, well, it brings us right back to where we started, the threat. And now, we've got a clock ticking.
It's not just him either. Big players like IBM are putting a real time frame on this. See, the idea that quantum could break encryption has been around since the 90s, but now they're predicting a machine powerful enough to actually do it could be built within the next 5 to 10 years.
So while this technology is being built, major institutions are already preparing for the fallout. Think about it. Our entire internet security system was designed in a pre-quantum world. That's why the US government has been working on quantum-safe standards for over a decade. And companies like Google, they're already deploying them. The race is definitely on.
And that leaves us with this final, kind of mind-blowing thought. We are standing on the edge of a completely new era of computation.
If a machine can simulate reality at the atomic level and shatter the foundations of our digital security, what are the problems we haven't even thought to ask it to solve yet? If you enjoyed this, subscribe to AI in 8 minutes and never miss what matters.